This is the overall hardware setup for the project titled A Power Quality Improved EV Charger with Bridgeless Buck Converter. These are the basic hardware blocks involved. The first block is the Buck Converter block. These three blocks together form the flyback converter. This is the controller block. These two are the isolation blocks. This is the power supply block for the isolation. The blocks in detail. The first block is the Buck converter block, wherein we have used two switches, 4 inductors and capacitors. The two switches are MOSFET IRF 840. These three blocks together form the flyback converter. This is the microcontroller block, wherein we have used PIC 16F877A microcontroller, which is a 40-pin IC. The input to the circuit would be at 12 volts from the transformer. Of the 12 volts, only 5 volts would be used for the operation of the microcontroller. That is done using the regulator IC 7805. This is the crystal oscillator, which is used to give clock pulses. The isolation for the MOSFETs present in the Buck converter and the MOSFET present in the flyback converter is provided by the three optocouplers used here. We have used TLP250 for the isolation. These are the optocouplers. For each MOSFET, one optocoupler is being used. The operating voltage of optocoupler is 12 volts, that is supplied by the power supply board that is present here. This is taken by the 230 volt is stepped down using a 12 volt transformer, and from the transformer it goes to the power supply board. From here we supply a 12 volt to the optocouplers. The Buck converter's output would be in negative polarity. The flyback converter, we cannot achieve power factor correction using the flyback converter. Since we need a positive output polarity for charging, we combined both the Buck converter and the flyback converter, and with the help of the Buck converter we can also achieve a power factor correction. Hence the power quality is also improved. Now we will switch on the circuit and verify the input and output voltages. We have switched on the circuit and we can see the LED glowing. This shows that the circuit is working. We have connected the probes of the multimeter across the input points. The input to the circuit is AC. We can see an AC input of around 22 to 23 volts. AC input is given here to the Buck converter circuit, and now we will verify the output. The output of the Buck converter is of negative polarity. That can be verified in the multimeter. We can see a negative value. This is the output of the Buck converter. After that, we will verify the output of the flyback converter, wherein both the Buck and flyback are combined, and we can see a boosted output of 110 volts. There would be a fluctuation of 1-2 points. That is because we can see the voltage that is boosted is around 1 to 110 volts. So the 22 volts that is given as input is boosted to around 110 volts. This can be used, this output, DC output, can be used to charge vehicles, electric vehicles. Even This is power quality improved EV charger with bridgeless converter, where converter and flyback converter are combined together to give a boosted output of 110 volts DC.